So let's continue talking about sets. We're going to look at the complement of a set. So the complement of a set, and this is denoted with a little apostrophe. We call this A prime if we have the little apostrophe, or you can put a C in the exponent to indicate that you're doing a complement. The complement is all of the elements that are not in A. So remember earlier we defined the universal set. That sort of defines the universe where you exist, and so A is going to be a subset of the universal set, and then the complement is everything else. In set builder notation, this would be the set of everything in the universal set that is not in A. Okay? So for example, if our universal set is all the integers 1 through 10, and A are the integers 2, 3, 6, 9, and 10, then A complement, A prime, would be everything that was in U that is not in A. So 1 is in U and it's not in A, so our complement would have 1. 2 was in A, so we won't have a 2. 3 was in A, we won't have a 3. 4 is not in A, so we'll have 4 in the complement. 5 is not in A. 6 is in A, so we won't include 6. 7 is not in A. 8 is not in A. 9 is in A, so we don't include, and 10 is in A, so we don't include. So our complement then would be the set of 1, 4, 5, 7, and 8. You can think of this also in terms of a diagram. If you imagine your universal set is everything within this little rectangle. So I'm thinking of this as like a piece of paper. So there's my universal set. A lives somewhere inside of there. So let's say this is the set A. Then A complement is everything that is outside of A. So A complement would be everything that's in the universal set but not in A. So if you imagine you had a piece of paper and you cut out the A, anything that's left over is your complement. And that's what we see here in our example. A complement gave us everything that was left over once we removed A. Okay, so now let's look at some set operations. So how can we combine two sets together? The first thing we'll consider is a union. A union, I think of a union as kind of, you take everything in set A, everything in set B, and you dump them into one bowl, and that is the union. And the symbol for the union kind of looks like a bowl, so that's how you can remember that. It's the set of elements where the element either belonged to A or to B. Now, if you have a common element between A and B, then you only count that element once. So let's think of our sets A and B within the larger universal set, like we did before. So let's say here's A will be the blue, and let's let B be the red. The union is going to be everything that is within A or B. So that's all of A and all of B. So we get anything that was in the two of them. And it could be, and it includes the part where they overlap. We just would only count those parts once. So the union is given here by the green. So A union B would be this green, this whole, looks kind of like eyes. Okay? Now an intersection is the overlap of the two sets. Or you could, and just like a union, you can do this with more than two sets. So there's nothing that says that you can only union or intersect two sets. So if we have our universal set, right, that's our larger space, and then we have set A and set B, the intersection is only the space where they overlap. So it's just that little part in the middle. And there's no guarantee that sets have an intersection. So if they intersect, then it would be anything that is shared in common between them. So we would have A intersect B, and that would be that little part where they overlap. If two sets do not intersect, then they are said to be disjoint. So that means that their intersection is the empty set. So as far as our picture goes, two sets would be disjoint if they don't overlap with each other. So say here's A and here is B. Their intersection is empty. And so this would be an example of disjoint sets. A and B would be disjoint because their intersection is the empty set. Okay. So let's take a look at an example here. We have 3 different sets, and we want to look at some unions and intersections and see what we get. Alright, so our universal set, right, this is defining the universe that we're living, that our sets are part of. So we have the integers 1 to 10, and then R, S, and T are different subsets of the universal set. So let's see, if we want to union R and S, so this will be the set that has all of the elements that are either in R or S, or both of them. So we'll get 1, because that's in R. The next integer we have is a 2, and that's in both of them, so we'll include a 2. And now I'm not going to include it twice, I only need to represent it once. So we have 1, 2, 3. 3 is not in S, but we still include it. 4 is in both of them, so I'll include it once. There's no 5. The next thing we have is a 6 from S. There's no 7, and then we end up with an 8. So the union is everything that was in R or S, and anything that was in both of them, you only represent it once. Now let's look at the union of R and T. So I'll go ahead and get rid of these. So R and T, again, we're just listing anything that was in R or T. So we get a 1, a 2, a 3, 3 is in both of them, a 4, and then we'll finally end with a 5 from T. So we'll have 1, 2, 3, 4, and 5. And that represents all the elements that were in R and T. Now if we do the intersection wants only the elements that are common to both of them, right? We're looking for the overlap. So let's see. T is the smaller set, so I'm going to use T and try to find the elements that are in R. So 3 is in T, and we have a 3 in R. So 3 will be in the intersection. 5 is not in T, or 5 is in T, but there is no 5 in R. So we won't include a 5 in the intersection. So our intersection would just be 3. Okay? Now let's see, the next one is asking us to combine a couple of things here. We want to look at T complement intersect R. Alright, so let's go ahead and write down T complement so we can reference it. Remember, the universal set is all the integers from 1 to 10. So T were the integers 3 to 5. So its complement would be all the integers from 1 to 10 without 3 and 5. So this would be 1, 2, no 3, 4, no 5, 6, 7, 8, 9, and 10. Okay? And so now we want to intersect T complement with R. So let's find the common elements between our new set, T complement, and R. It looks like R is the smaller set, so I'll use that to compare to T complement. So let's see. There's a 1 in R and a 1 in T complement. There is a 2 in R and a 2 in T complement. There is no 3 in T complement, so we won't keep the 3, but there is a 4 in R and T complement. So our set then is going to be just 1, 2, and 4. Those are the elements that are in common between R and T complement. Now, last but not least, we want to look at the union of S with T complement. So now, notice that the complement is on the outside. So we're going to do the union first, and then we will complement it. So we're going to have to come up with a new set in complement. And then we will take the complement of that set. So let's go ahead and union S and T. So I'm going to write that over on the side here. S union T. So let's see, we'll get a 2, a 3, a 4, a 5, a 6, and an 8. Remember, a union has everything that's in S or T combined together. So I'm just listing them in order, so it'll be easier to find the complement. So now we need to complement S union T. Now remember the universal set, all the integers from 1 to 10. So if I start at 1, 1 is not in S union T, so it will be in the complement. So I want 1. I can't use 2, 3, 4, 5, or 6, but I could use 7. 7 is in the universal set, right? But it is not in the union. We can't use 8, and so then we'll finish with 9 and 10. So altogether, if we, so here's another thing, so that sort of how you can check your complement. If you union S union T complement with S union T, you should get everything. You should get the universal set. And that's because the complement is everything in the universal set that's not in S union T. So if you union the two together, you should get your original universal set. And let's see. Let's just sort of go through. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. If we union these two sets together, we get exactly the original universal set. So that's another way that you can think about unions if you want to make sure that you sort of check your work in that way. Alright, that's all for now. When we come back, we'll be looking at some basic counting techniques and using sets to help us count.